Right, let's dive into the ultimate challenge. Today, we're conquering compiler actions for translating recursive code. We're going to tackle this like a true exam samurai, slicing through the confusion with absolute precision and avoiding the traps that catch so many unprepared students. Welcome to the Explainer. This is one of the most notoriously tricky areas in computer science, but we are going to break it down so you can completely dominate your Cambridge papers. Look, whether you are in the thick of syllabus 9618 right now or you're building your foundational knowledge across 0417, 0478, 0983, 0984, or even 2210, the strategy we are unpacking today is going to be your absolute ultimate weapon. Now, I want you to imagine two students taking the exact same exam, Alex and Sam. When they're faced with a really complex recursive code translation question, Alex starts sweating. He panics and just decides to write down every single fact about compilers he has ever memorized. Just a total brain dump. Sam, on the other hand, panics about the clock. She writes a hurried, vague one-sentence answer and just skips to the next section. Well, spoiler alert, neither of these approaches works. Let's find out why.
So, what's really interesting about this question is that most students fail for two very specific, totally avoidable reasons. They either overload their answers with raw facts without any actual analysis, exactly like Alex, or they rush it and completely miss the command words entirely, like Sam. You see, when examiners look at your paper, they are not looking for a Wikipedia article on lexical or syntax analysis. No way. They are looking for targeted, precise answers that respond directly to the command word in the prompt. Alex lost marks because the examiner literally had to hunt for the actual answer, which was buried in this massive mountain of irrelevant code snippets. And Sam lost marks because a rushed answer completely lacks the depth required to show how a compiler manages memory addresses or call stacks during recursion. It's too superficial. But don't worry, because we are going to fix both of these exact flaws right now.
Here's our masterclass blueprint for today. First, core assessment objectives. Second, the procedural framework. Third, algorithmic thinking. Fourth, deconstruct, solve, evaluate. Fifth, the method mark strategy. And finally, critical examiner warnings. Let's get right into it.
Section 1. Mastering core assessment objectives. The absolute most crucial point here is understanding exactly what Cambridge examiners are testing before you even pick up your pen to write a single line of code.
Okay, so examiners want to see logical, structured reasoning and true analytical depth. They are actively testing distinct cognitive domains, specifically knowledge and understanding, application, and analysis. What this actually means is you have to prove you have a conceptual understanding that transfers seamlessly to unfamiliar recursive translation contexts. It is definitely not enough to just know what a compiler is. You have to apply that knowledge to show exactly how the compiler translates a specific recursive function, and then analyze how the call stack handles those return addresses. This assessment framework heavily prioritizes analytical depth over superficial breadth. If you can logically reason through how the compiler manages the scope of variables across multiple recursive calls, you are hitting all three of these domains perfectly.
Section 2. The Strategy Reveal and the Peel Framework. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Now, let's look at the framework that top-tier students use to secure maximum marks.
This table brilliantly illustrates how using the Peel framework, which stands for Point, Evidence, Explanation, and Link, directly counters Alex's raw fact-dumping and Sam's rushed, unanalyzed responses. Let's really break this down. Your point directly addresses the command word. Boom. Right out of the gate. Your evidence brings in the specific data from the recursive code provided in the exam. Then your explanation details the compiler action, for instance, explaining exactly how a stack frame is pushed. And finally, your link ties it all the way back to the original question. Think about it. If Alex had used this, his answer wouldn't be an overloaded mess. It would be a razor-sharp, laser-focused argument. And if Sam had used this, her rushed answer would have naturally expanded into a full analytical paragraph. This is exactly how you prove connected conceptual understanding to an examiner.
Section 3. Systematizing algorithmic thinking. Let's move over to the mechanics of your code and see how this builds into an undeniable, high-scoring strategy.
Remember, algorithmic thinking isn't just for writing code, it's a structural tool for writing your exam answers too. To master recursive code, you must execute these 4 specific steps of algorithmic thinking. Step 1 is step-by-step decomposition. You've got to break down the recursive loop into its base case and its recursive step. Step 2, data structure selection. Explicitly identify that a stack is the essential data structure the compiler uses here. You have to state that. Step 3, efficient code implementation. trace how the compiler generates intermediate code for these steps. And step 4, rigorous testing. Verify your logic. If you structure your written answer by following these exact operational steps, the examiner instantly sees a mind that thinks systematically. You are literally spoon-feeding them the logical sequence they are actively searching the mark scheme for.
Section 4. The procedural framework and transformation. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
By following this standardized procedural sequence, you will literally transform your red pen mistakes into green check marks right before the examiner's eyes. It's a 5-step transformation. First, you identify the key elements of the recursive function given to you in the prompt. Second, you apply relevant principles, things like how the compiler handles symbol tables and memory allocation. Third, you execute the analysis with incredibly clear working, maybe by tracing the variable states step by step. Fourth, you verify your results against the actual constraints of the question. And finally, you present your answer in the specific format requested by the command word. This sequence is your ultimate safety net. It actively forces you to slow down, process the problem systematically, and deliver exactly what the mark scheme demands.
Section 5. Interactive Workshop, Data Scan, and Flaw Finding. Now it's your turn for a 60-second challenge. Imagine a complex data table showing stack memory usage over time during a recursive call is right there on your exam paper. Your job is to scan the data, extract the core trend, and let's identify the exact sentence where a hypothetical student is just bleeding marks.
Okay, here's a massive secret. The biggest flaw students make in analysis is only listing similarities. Seriously, if a question asks you to compare iterative and recursive compiler actions, you absolutely cannot just say they both execute code. That gets you nowhere. You must contrast the differences and support each comparison with hard evidence to draw conclusions about their relative importance. For example, you need to explicitly state that while both achieve repetition, recursion utilizes the call stack to store return addresses and local variables, which massively increases memory overhead. Iteration, on the other hand, just relies on simple loop control variables. See the difference? You must use comparative connectives like whereas, however, or in contrast, and back it up with technical evidence. This right here is the exact difference between a C grade and an A-star grade response.
Section 6. Deconstruct, solve, evaluate. This is our speed writing methodology. Imagine we put 30 seconds on the clock for you to mentally outline one perfect Peel paragraph. Let's see how we apply this mantra under pressure.
You need to deconstruct, solve, and evaluate by working systematically through these 5 steps. This ensures every single point you make directly answers the command word requirement. So, in a speed writing scenario, first, you identify the given information, like what are the exact parameters of the recursive function. Second, break it into logical steps. Ask yourself, what happens on the first call, the second, the base case. Third, solve it systematically by mapping out the compiler's translation process. Fourth, check for reasonableness, meaning does your stack trace actually reach the base case, or did you actually just create an infinite loop? Finally, make justified recommendations if the question asks for optimization. Implementing this deconstruct, solve, evaluate loop is exactly how you write flawlessly under immense time pressure without ever sacrificing analytical depth.
Section 7. The method